Norbert Kovac, and I'm a technical support engineer at Midas. And welcome to this Midas Civil Webinar. The webinar today will be on single-span skewed composite PSC integral bridge designed to Eurocode. Okay, so we have already confirmed that you can hear us. So if you can't see the screen, then it might be because this is minimized. So just by clicking on the maximize screen button, you can maximize this. And also, if your screen goes blank, it might be because your screensaver has kicked in. So you might want to turn this off now. Okay, so a few things about GoToWebinar. If you would like to hide the dialog box, you can just click on the red arrow and this will be hidden. Also, if you have any questions, you can put this into the chat box and I will be answering these as soon as possible. Okay, so the content of my webinar is going to be about Midas, Midas modeling, application of loads and boundary conditions, analysis, result extractions, and design. So, about Midas. Midas is the largest engineering software developer in the civil structural engineering field. And we also, using Midas, a variety of large span bridges have been designed as well as conventional ones. So yes, on the left-hand side you can see a short list of the clients that we have, and on the right-hand side you can see some of the projects for which Midas has been used, such as Burj Khalifa, the Beijing Olympic Stadiums, Roski Island Bridge, and so on. Okay, so this is the bridge I'm going to be designing today. As you can see, it's a single span bridge. It's 15 meters long, 11.15 meters wide. It has a skew angle of 15 degrees. The slab on the girders is 200 millimeters thick, and the girders are 750 millimeters thick. The main girders are integrally connected to the abutment. The abutment is 3 meters deep, and the piles are 10 meters. Okay, so now moving on to the software itself. This is the Midas interface. As you can see at the top we have the ribbon menu. We have a variety of tabs which are structured in a logical manner. These help the users to carry out their designs. And as you can see, we have a load analysis and so on and so forth. We have two tree menus. The second tree menu I will talk about very soon, but first let me explain the one on the left-hand side. In order to speed up the process of the modeling, I have created some of the materials and some of the sections. And if you want to see any of the materials, then you can just simply right-click on this and go into Properties. And then here you can see all the material properties. As well, if you want to change anything, you can do that over here. Okay, so cancel that. The same is applicable to the time-dependent materials. You can just simply right-click on this, go into Properties, and here you can see the properties for the slab. Also, if you click on Show Results, you can see the creep coefficient and the shrinkage strain graphs. Okay, and finally for the sections, the same applies. You can just right-click on the main deck, for example, go onto Properties. You can see all the section properties over here. If you want, you can click on Calculate Section Properties, so all these will be recalculated, and then also you can see the section on the left-hand side. Okay, so let's start the modeling. I will go onto the Node Elements tab, and we'll create the first node. So just simply create node in the origin, press Apply, And as you can see, the node has been created over there. Now I'm going to create a line out of this node, so just simply go into extrude. Here you can define whether you want to extrude a node into line element, a line element into planar element, or a planar element into solid. Now I'm going to extrude a node into line element. The material and the sections are suitable, and just going to define by how much I will be extruding it and press apply. By pressing Ctrl and the scroll button, you can rotate this and you can see your own section. Okay, so moving on to the top view now, and I will take up the hidden view. Okay, so now in order to account for the skew of the bridge, I'm going to rotate this, so just highlight the entire line. I'm going to rotate the nodes. I'm going to be moving these and by 15 degrees, and it will be about the z-axis. Okay, so by simply pressing apply, you can see that this has been rotated. Let me just turn on the nodes so you can see where the nodes are. Okay, there you go. As a next step, I'm going to create the longitudinal girders. So for that, again, I'm going to select the line. I will be extruding this. So just click on extrude, and I will be extruding into the X direction by 15 meters and only one time. Okay, press apply. As you can see, this has been created. Moving on, I'm going to create the transverse element. So for that, I will simply copy the left-hand side of the bridge. So go on to translate, specify 1 meter, and do that 15 times. And I will be intersecting node and element. And simply pressing apply, you can see that all the transverse elements have been created. Okay, as the next step, I'm going to create the abutments. So for that, I will select the left-hand side and the right-hand side of the deck. I'm going to use the select by polygon option for that, and just simply highlight both sides. Okay, now I'm going to be extruding these. So as you can see, the extrude option is very useful and often used. In this case, I'm going to be extruding line elements into planar elements, and the material is going to be concrete. Okay, and it will be -1 meter 3 times. Okay, by pressing apply and rotating the model, you can see that this has been created. As the next step, I'm going to create the piles. So I'm going on to the right view and select the node which I'm going to extrude and create the piles from them. Okay, again, I will be extruding, only in this case it will be extruding nodes into line element. Again, this will be concrete material, and the section will be piles. I only need to change the number of copies and press apply. Going to the isometric view, you can see that the bridge has its piles now. Also, turning on the perspective view, you can see more real view of this. Now I'm going to sort out the sections for the main deck. So I will go on to the front view, take off the perspective view, and prefer to work with the mathematical model, and just simply select the main deck and activate this. By activating these elements, everything I'm going to do from now on will be applicable only to these elements and not to the rest of the model. Okay, so as you can see it now from the top view, we are missing the elements on the left hand side and right hand side because these have been extruded into plates. So all I need to do now is draw these in. So just click on create element and just simply click on the first and the last node on both sides. Okay, so now I can select the entire bridge, or even better, I can turn on a filter for into the X direction. That means that from now on I'm going to work with only the elements that are into the X direction. So I can select everything and just activate these. Okay, so now I will assign the elements. So for that I'm going to select these elements, and in order to show you how this works in Midas, let me turn on the perspective view and go into the right view and just simply drag and drop edge beam right. As you can see, this has changed the section property and its position as well. Okay, so in order to save time, I'm going to quickly do the rest. So there will be right side. On the left side we will have left side, and we will have the edge beams on the left. Okay, so turning on the perspective view, you can see that these have been changed. Okay, now finally we need to assign the transverse sections. So for that, again, I will be selecting the main deck, although in this case I will have no filter on. Select the main deck and activate only that. Excuse me. Now by selecting everything and putting on the filter into the X direction, I can unselect all the elements that are in the X direction. Therefore I'm left only with the transverse elements. Therefore I can simply drag and drop the transverse sections. And now when I'm double clicking on it, you can see that these elements have been assigned to it. And now I can also drag and drop the material. Okay, so turning on the perspective view and activating everything, and looking from the isometric view, you can see how the entire model has been created now. Okay, so I'm going to move on to my next model, in which I have created some groups. I have created these groups in order to speed up the process of modeling. So as you can see, I have structural groups, and if I double click on these, you can see which elements are assigned to these groups. Okay, I have also created the boundary group and the load group. For these right now, even if you double click on them, nothing's going to happen because these are not yet created. And I have created the load cases and one tendon profile. If you want to see that a tendon property, if you want to see that, you can just right click and go into properties, and here you can see the tendon properties. Okay, so first I'm going to define the boundary conditions. So for that I will start from the front view. I will select the deck, and as you can see my filter is turned on to X, so I will have only the elements in the X direction. I can activate these, go on to the top view, and I'm going to create pin connections. I'm going to create pin connections on the left hand side and on the right hand side as well. So in order to do this, I'm going to use select by polygon and select the element on the left hand side. Okay, so by going on to beam and release, so I was at the beam and releases, so I'm going to define the beam, the boundary group name first. So there will be beam and release, and because I need to create the pins on the left hand side, I will be releasing these in for the I node. So just simply unclick for the J node and press apply. And I'm not sure if you can see it, but there are small green circles which represent that the beam and releases have been created. Okay, so I'm going to repeat the same procedure on the right hand side. So again, select by polygon and I'm going to select the right hand side, and I will be releasing the J node for these elements. Okay, so by pressing apply, these have been assigned the boundary conditions as well. And now if you double click on beam edge releases, you can see all the elements that have been assigned to these and all the restraints as well. Okay, so moving on to the next part, I'm going to activate the entire bridge, and I will be selecting the piles. So from sections, I can just double click on piles, and you can see that all the piles have been highlighted. Now I will be creating the boundary conditions for these ones. Basically, this is the part where I'm accounting for the soil structure interaction. So by clicking on pile springs, here on the figure you can see that the software is going to generate us springs that account for both the horizontal and the vertical restraint. Okay, and in order to do that, we need to specify the pile springs data, so the soil type, the ground level. So for that you can just click on the screen. You need to specify the pile diameter and the coefficient of subgrade reaction, and simply press apply. And as you can see, these have been created. Okay, so I've just noticed that I forgot to choose the boundary group name. So what I can do, there are two options in Midas to correct this mistake. You can either go back with Control Z, or just simply select all these springs and then drag and drop pile springs. In this case, I will be just using Control Z and select previous. And by pressing apply, you can see that these have been created. And if I go on to the initial view and I double click on pile springs, you can see that the nodes have been highlighted. Okay, in the left hand side in the works tree, you can see that the software has created linear and multilinear springs as well. By double clicking on these, you can see which nodes have been assigned which springs. Okay, so let's unselect these nodes. Moving on to loadings, I'm going to start with the self-weight. So go into static loads and self-weight. All I need to do for this, I need to specify the load case name as self-weight and the load group name as self-weight, and just input -1 for Z as the weight of the structure is going to act downwards. So just simply press add, and as you can see, this has been created for you. As in the next step, I'm going to create the wet concrete and the surfacing loads. So for that, again, I will be selecting all the elements in the deck that are in the X direction. So just simply activate these and go on to the top view. Okay, and here I'm going to select all the elements that are in between the two edge beams, and I will be applying element beam loads onto these. So again, we need to specify the load case name and the load group name, so both as wet concrete, and just specify the loading as -10 and press apply. When rotating this, you can see that the software has applied the UDL onto the model. Okay, so now if I click on select previous, we can apply the surfacing as well, because it will be applied onto the same area, and just select the loading for this as well. So let's say 9 and press apply. And now you can see that this has been applied as well. So now I can activate everything and go on to the initial view. Next step, I will be creating the earth pressure. So in order to do that, I will select all the plate elements from the tree menu. As you can see, within the tree menu you can do a variety of things, and it's very useful and makes your speeds up your work. So I'm just activating all these plate elements and selecting the left hand side first, go into hydrostatic pressure, select earth pressure for both load case name and the load group name, and now just input the reference level, the constant intensity, and the gradient intensity, and just simply press apply, and you can see that this has been applied. Okay, so now I'm going to repeat the same procedure on the right hand side. So just simply select all these plate elements, and I'm just going to change the sign of the loading as it will be in the opposite direction. And as you can see, this has been created. Okay, now I can activate everything. Again, go onto initial view and close this window down. Finally, we are left with the pretensioning. So in order to create the pretensioning, first I need to create the tendons. So for that, I'm going into structures and tendon template. The tendon template I'm going to create at the same time. So basically, because the section for main deck 1 up to main deck 12 is the same, I can assign these elements to a group and just create one tendon template and apply that to all the elements. So just simply double clicking on these and press add, you can add all these elements into one temporary group. Okay, so quickly add these in, press OK, and now you can see in the section tab that all these have been added. Because these elements are standard sections, we can use the auto generation function and just simply press OK, and you can see that the software has created you with all the tendon templates. Here you can select the tendons and delete them. You can delete as many as you wish. Let's delete these ones. You can select tendons and you can move them. So just go into move and move them by 0.1 meters. And also you can see the little black circles will define where your tendons are going to be. Just simply pressing apply, you can see that this has been shifted. You can also select the tendon, modify, and you can do debonding. So in this window you can just input where the tendon will begin and where it will end, and just press OK, and your tendon will be debonded. Okay, so now by pressing apply, all these tendons will be created. So now I can select all these and hit delete, and I'm going to repeat the same procedure for the right hand side and the left hand side. So just click on auto generation, OK. Again, the software is going to create you all the tendons. You can delete and press apply. Okay, again, select them, delete, and finally go on to the left hand side, go on to auto generation and press OK, and press OK again. Okay, so by looking at the perspective view, and let me activate the tendon profile point. So just press OK. You can see it from the top view. So when looking at the top view, you can see small pink nodes. These are the nodes that define where your tendons are starting and ending for those that you have debonded. Okay, and by going on to the front view, and zoom in a bit. Okay, so in the front view you can see all the tendons, for example on the left hand side, the ones that I have deleted. Okay, so now that we have all of our tendons, our next step is to create the pretensioning load into them. So just go into load, pre-stress, tendon pre-stress, and here again I will just select the pretensioning for the load case and for the load group name, and then select all the strands. Okay, now I'm going to apply a force on both ends, and the force will be 250 kilonewtons. Okay, and simply pressing add, the software is going to generate you all the pretensioning. Okay, and you can see this in the static load case for pretensions. If you right click on this and hit display and you zoom in, let's see if we can see them. Yes, there you see 250 and it's a false. Okay, so let's go back onto the initial view. Now that all of our boundaries and loadings have been created, I will move on to the moving loads. So again, let's select the main deck. Just activate this, go on to the top view, and for moving load, again, we need to select the code. So I'm going to choose Eurocode now. And for simplicity, I'm going to define only one traffic lane and one vehicle, and I will show you the other lanes in my next model. So just simply hit add, input a name. So I'm going to create a sidewalk first. It will have an eccentricity of 1 meters. Let's say wall spacing of 1, lane width of 2. The load will be applied onto our crossbeams, and our crossbeam group is the transverse one. The skew angle both at the start and end is 15 degrees. And we have to select a line of reference. So our line of reference, just select the first and the last node. So this is the line of reference to which the eccentricity will be -1 meters. Okay, so by simply pressing OK, you can see that this has been created. Okay, so moving on to the vehicle. As you can see over here, we can all add standard vehicles and user-defined vehicles. I'm going to add standard. So in the standard names, you can see that we have an extensive amount of standards. So now I'm going to use the road bridge, and we have LM1 to 4. And for now, let's just pick LM3 UK National Annex. Okay, so here you can see the loads. You can see the explanation of the P's and the D's. Furthermore, you can choose your vehicles, so from SV80 to SV196, and you can select SOVs as well. Furthermore, you can specify your own phi factor, so let's say 1.12, and hit OK. And as you can see, this has been created. Okay, these are blue because they are not yet connected. In order to connect them, we need to create a load case, and I will show that in my next model. So in order to save up time, I have applied all the traffic line lanes. So let me display them. As you can see here, we have 2 sidewalks. Also, we have 2 lanes and 1 remaining area. Furthermore, here are the vehicles. This is a footway load. This is a LM1. As you can see, the adjustment factors have been changed as well. And we have the third vehicle as a LM3 UK National Annex SV100. Okay, and in order to connect these, as I said previously, we are using the moving load cases. So for GR1, all you need to do is just select the load model. Whether you want to ignore or not the psi factor, you need to choose your load case data, so which vehicle and footway you want to use, and then finally you just need to assign the lanes. So the line lanes go into the selected lanes section, the sidewalks go into the footways, and remaining area into the remaining area. And the same applies to GR5. Only in this case we have LM1 and 3 multi-straddling. So in the case you have a variety of lanes, you need to specify which of these lanes are straddling ones, which you can do over here. Okay, so that's what I wanted to say about moving loads. Let's move on to construction stages. So you can define the construction stages within load and construction stage. Define construction stage. Just simply hit add, And first we need to specify the name of the construction stage, the duration, and then we need to activate the elements, boundaries, and loads. So in the first construction stage we only have the substructure. This will be applied at 28 days. The boundaries will be the pile springs, which are assigned to the substructure, so just add these in, and the loads are the self-weight. And again, just add. Simply pressing apply, this has been created. So moving on to the next construction stage, again specifying the elements. In this case we will have the entire deck, and again this will be at 28 days. The boundaries, we will activate the beam end releases because at this point the girders are just simply supported on the two abutments. The girders will be integral with the abutment as soon as the slab gains strength. So add these in, and for loads we will have the wet concrete load and the pre-tensioning. Apply, and finally for the third construction stage we will have a long one, so that's 10,000 days. The elements that we're going to activate are the transverse and the edge beams. Again, this will be at 28 days. Just simply press add. For boundaries, in this case we remove the beam end releases for the same reason which I have mentioned previously, because the composite action kicks in at this stage. And for loads, again, we will remove the wet concrete. And at this point I'm going to add an additional step for the surfacing, so that will be at 21 days. Just simply add these in and save the results for the additional step as well. And now just simply go on surfacing and add this at 21 days and hit OK. There you go, all of our construction stages have been defined. Next I'm going to define one composite construction stage. So just hit add, and the stage where we activate these is the second stage because that's where we have our main girders. The construction sequence is that we first have the precast girders. These will be activated in the second stage. The age will be 28 days. Our second material, or part 2, is the slab. This will be activated in the third construction stage, and the age is 7 days. By simply pressing OK, you can see that this has been generated. So moving on to my final model, let me show you how these have been created. The reason why I'm showing it to you here because it's a very simple procedure, so you can understand it easily. As you can see, we have 3 non-cracked and 3 cracked sections. These are all have the same details, except that the cracked sections have a 0 scale factor for stiffness. So let me show you that. So the cracked sections for the main deck are assumed to be above the abutment. So as I mentioned previously, the activation stage and the construction sequence is the same, except that the stiffness scale is 0. Whereas for the uncracked sections the stiffness scale is 1. Okay, so let's close that down and let's have a look at the construction stages. So this is the first one, this is the second one, and there you go, the third one when the slab has been cast and we have the edge beams. Okay, so let's move on to the results now. So going on to deformations, displacement contour. One of the great advantages of Midas Civil is that you can check your results for every single construction stage as well as for the post-construction. So you can check it for construction stage 1. For example, let's see the displacement contour due to dead load. And let's have a look at the legend and the deformed shape. Press apply, and you can see that on the right hand side you have the legend, and on the left hand side you have the deformed shape. And as you scroll down between the construction stages, you can see that in the second construction stage, this is what your model looks like, and in the third one, like this. Okay, so let's move on to forces. Let's look at beam forces and moments. Again, all the load cases and results can be checked for every single construction stage. And something I would like to point out is that in this case, you can check for tendon, creep, and shrinkage, both primary and secondary effect. So you can check all of these separately. So for now, let's just have a look at the summation and apply. Okay, so let's see in the second construction stage and the third one. Okay. Also, using this tab, clicking on the three dots, we can check for the coexisting forces. So let me first switch to post-construction stage. So moving on to the post-construction stage, and now clicking on the three dots, we can check for the coexisting forces. So let's see for the GR1, and just for the I part, hit OK. And as you can see, you have the actual shear, torsion, and moment forces over here. And by right-clicking on the screen, go to View by Maximum Value Item. You can choose which values would you like to select. Let me just select all of them and explain as soon as the table is generated. So basically, the software is going to generate you a table in which you have the component, and when that is the maximum, you can see the coexisting forces. Let me first change the units, so to meters. So to meters and kilonewtons. It's much easier to view them this way. Okay, so let's see, for example, for element 17, when the actual force is maximum, i.e. 107.2, you can see that these are the values for shear, torsion, and moment. And by right-clicking on this, you can export this into Excel. All of our tables are fully Excel compatible, so you can export any table. Okay, so let's move on to the model view. And finally, looking at stresses. Let's see the beam stresses. You can check it for, let's see, for earth pressure. As you can see, you can pick the components you wish to see. You can see the total. You can see part 1 or part 2. And also you can check for excuse me, for stresses due to actual shear or bending moments. Okay, so by pressing apply, you can see the result. Okay, so let's move on to the moving load tracer. So moving load tracer, beam forces and moment. Here you can select the element for which you would like to see the most severe case. So just simply click on the model and press apply. And in this case, the software is going to generate you the most severe positioning of the live loads, as you can see it on the screen. You can create the you can see the maximum values, and also you can create a static load case out of this and use that in order to see the coexisting forces by clicking on write minimum maximum load to file. Okay, and finally, another very useful feature which I would like to point out is in the results tables, our tendon loss. So for tendon stress losses, Midas provides you these losses broken down into components. So as you can see, you can check the relaxation loss, the creep shrinkage loss, elastic loss, and so on and so forth. And you can check these for every single strand and for each construction stage that you will be interested in. By simply pressing apply, you can check the values, and also you can change the units whenever you want. Also, if you right click on this, you can export this into Excel and check the tendon time dependent loss graph. So here again you can check it for each tendon, and you can see how this graph varies. Okay, so moving on to the design, PSC design. Let's see the initial view. As you can see, we can choose from a variety of codes again. You can select your parameters that you would like to work with. Again, you can choose the design code and its national annex. We have the British code, British national annex, and also you can choose your output parameters over here. Okay, so for the design data, I have designed the material for the precast girder. So if you click on precast girder, you can carry out the design over here. For both the girder and for the slab, you can choose the code and the strength of the concrete, and the same applies for the rebars. You can choose the code and the main rebar grade. Okay, design output and position. So for design position, this is a very useful feature, especially when you're generating a large model. So if you know that your the most critical loading will be for certain elements, you can just select those elements and carry out the design only for those. This way you can save a considerable amount of time doing your design. Also, you can create an output. So the output will be based on the elements that you're selecting again. In my case, I have selected 2 elements, and let me show you that the software is going to generate you a comprehensive Excel spreadsheet. In this spreadsheet, you can check the design conditions. For this, the software is going to show you the clause of the Eurocode. It's going to show you tables, the tendon template. Again, it's going to show you the formulas that have been used in order to calculate the values, on which clause these formulas are based on. You can see the tendon profile information, and furthermore you can check for all the checks that the software has been carried out. You can see whether they're okay or not. If the check is not suitable, let me scroll down, the software is going to highlight that in red. Okay, so let's move back to my model. Okay, moving on to serviceability load combinations. In order to create this, first we need to create the load combinations. So that you can do in results, load combinations. And I have created for the concrete design. You can input these manually, or you can auto-generate these. So by simply clicking on auto-generate, you can select the design code, for example Eurocode. You can choose the load factors, leading variables, and traffic loads. Also, you can specify which load case you want to be characteristic and which one to be frequent value. Okay, so now that we have our load cases, we can close this down, and these can be specified in the PSC tab for serviceability load combinations. Now you can specify for quasi-permanent, frequent, and characteristic values load combinations. Okay, so finally in my model I have also added in the shear connectors. In order to account for the shear in the horizontal plane, you need to specify these. So I'm using smooth surface. The angle is 90 degrees. Let me change the unit in this case. So into millimeters and newtons. Okay. So my area of shear reinforcement is 785 and Fy is 500. And as soon as you press apply, these will be defined in the software as you can see it over here. Okay, so finally, instead of going into the results tables and showing you more tables, I'm just going to show you the result diagrams. So PSC result diagram, you can see the options over here. You can check for forces and stresses. So by checking for the forces, hit apply. Let me go into solid. As you can see, I have carried out the design for the element that is at midspan and just above the abutment. So the solid line, the solid infill shows the design value, and the barred section is the resistance of the element. So as you can see, in this case, the elements are highly over-designed. But from a perspective of stresses, and let's press apply, and as you can see, the element at the midspan fails just by a little, but it fails, and the element on the just above the abutment is suitable. Okay, so by using these, you can check for any element within your model, and you can save yourself time within the checking process. Okay, so that's the end of my presentation. Thank you very much for your attention. And if you have any questions, you can put them into the chat box or send them to uksupport@midasuser.com. Thank you again, and goodbye.